So here is a little aside focusing on nuclear fusion in a way that it's taking place in stars, not very different from our sun. So here we look at hydrogen fusion, and the way the sun turns hydrogen into helium is in several steps. First we have the process where two hydrogen nuclei or two protons form deuterium with a release of 1.1 mega electron volts. Then capturing another proton, it forms tritium. And when two tritium nuclei meet, they might finally form helium and kicking out another two protons that can be taking place in other fusion processes. And the total amount of energy that is then released in the net effect of bringing four hydrogen nuclei into one helium is that 7 mega electron volts of energy are released that we may eventually perceive as light. So this here is like an artist's impression of a forming star, a young star with a disk around it, and something is defined as a star only when it's been able to fuse hydrogen into helium in its core. So schematic picture, we've got four hydrogen nuclei, they fuse together and form helium. Once the star runs out of hydrogen, for the sun not much will happen anymore, but for massive stars the temperature in the core will go up. Helium doesn't fuse as easily because it has a higher charge, so the Coulomb repulsion is larger, and we need higher temperatures to bring them close enough together. So when the temperature rises, then we may get an effect where three helium nuclei fuse together to form carbon. Carbon eventually, when we're slowly running out of helium, may start to capture some helium from the shells around it to form oxygen. Oxygen may capture more helium and turn into silicium. Silicium might eventually, if the temperature gets high enough in the core of a star, fuse to form iron. Now what we learned is that iron is one of the most stable nuclides. I cannot make it bigger and get any energy out. If we were to try to fuse iron, I would actually have to put energy in. And well, as we see, stars release energy, so they are not really in the process of giving energy into itself. So what may here you have this structure, so called an iron structure, different layers with small core of iron and then layers of silicium, oxygen, neon, carbon, helium, and the outermost layer is mostly hydrogen. So the core builds up, iron gets added to it, silicium gets fused, and the temperature in the center goes up, but eventually the gravity takes over and we get a so-called supernova explosion. So what happens is in this explosion is that the star, or rather the nucleus of the star, completely collapses. Gravity takes over. Any pressure, any radiation due to the previous fusion effects is no longer balancing the pressure. So everything falls in, and a lot of gravitational potential energy gets first converted into kinetic energy. So now there is a new source of energy available, and this may allow us to form heavier nuclei such as silver, gold, or for instance plutonium and uranium. Now, and this is then another picture of a young star. So after a supernova, a heavy star is dead, no longer exists, but a lot of the outer layers are blown into space, and eventually they will be picked up by clouds and form new stars. So in our own solar system, it's like a third or fourth generation solar system. It contains a lot of iron and uranium and silver and whatnot, and all of that was previously formed in the supernovae of heavier stars.